Hi guys, in this video I'm going to run you through everything you need to know about your first year of integration for A-level maths. Every section has been timestamped so you can easily jump to a section or rewatch it if you need to. Hope this helps. Integration is an operation that acts on a function. The elongated s is the integral sign and the dx is called a differential. The fundamental theorem of calculus states that integration is the inverse operation of differentiation. In other words, if we start with a function and differentiate it, we can return to the original function by integrating. This means the answer to an integral is a function that differentiates back to the function we started with. However, because when we differentiate a constant it becomes zero, we need to add a constant to the answer for an integral. Let's integrate 2x. Using the rule for differentiating powers of x, we can see the derivative of x squared is 2x. However, we could say the same thing for x squared plus any constant. So the answer to our integral is x squared plus c. Let's use our knowledge of differentiation to work out how to integrate powers of x. First, let's recall to differentiate a power of x, we multiply by the current power and then reduce the power by 1. The inverse process would be to first add 1 to the power and then divide by the current power. Let's apply this process, but starting from x to the n this time. First, increase the power by 1 and then divide by the power. Remember, if this is the correct result, it should differentiate back to what we started with, x to the n. So let's differentiate to check. We can see our formula checks out, but to get the full answer to our integral, we need to remember to add a constant. We can use this formula to work out more useful formulas for integrating powers of x. First, let's look at integrating x to the n multiplied by a constant. The process of integration, similar to differentiation, isn't really affected by multiplying constants, so we can pull them out of the integral. Now we can just apply our formula from before to get the final result. Next, let's consider the integral of 2 powers of x under addition or subtraction. Similar to differentiation again, to integrate we can simply integrate the terms separately. The last thing we need to know is how to integrate a constant. We can think of a constant as itself multiplied by 1, and then we can rewrite 1 as x to the power of 0. From here, we can just apply our formula again to get the answer kx plus c. Here are the results we just derived for you to take down if you want to. As an exercise, you could also differentiate them to check you get back the original functions we integrated. We started this video stating that integration is the inverse of differentiation. So suppose we are given a derivative. To find the original function, we can first integrate the derivative. To find the constant of integration, we need to know a point that lies on the original function. Suppose we know that the point 0, 3 lies on our function, we can then substitute that point in to solve for c. For A-level maths, we need to be able to evaluate definite integrals. Definite integrals have limits at the top and bottom of the integral sign. To evaluate a definite integral, first we integrate the function normally, but then either write a straight line or square brackets with the limits. Next, we pass the top limit through our integrated function, and then the bottom limit, subtracting the outputs. Let's do a simple example and integrate 2x plus 1 from 1 to 2. First, integrating 2x plus 1 gives x squared plus x. Now we substitute in the limits 2 and 1 and subtract the output of 1 from the output of 2. You might have noticed I didn't include an integrating constant for these definite integrals, and that's because it would make no difference if we did. Let's evaluate a definite integral including a plus c to demonstrate. First, we integrate our function, and this time let's include a constant of integration. Next, we substitute in our limits and subtract the outputs. Simplifying, we can see the constant of integration cancels and does not change the output we originally wrote down. We can use definite integrals to find areas beneath curves. Suppose we want to find the area between some function and the x-axis, starting and ending between two values of x. We can calculate this area integrating the function and using the x values as the limits. Something we have to watch out for when finding areas is if the area is above and below the x-axis. To demonstrate this, let's find the area between y equals 2x and the x-axis from -2 to 2. If we try to find the area with just one integral from -2 to 2, we calculate the result to be 0, which is clearly wrong from the diagram. To see why, let's integrate the areas above and below the x-axis separately. We can see the first area comes out negative as it's below the x-axis. So what happened earlier was our integral added these two together, which came to 0. To counteract this from happening, we can split up all the area that is below the x-axis and then add them, but as a positive value to get the total area. Something else we need to be able to do is find the area bound between two functions. We can best understand how to do this by visualizing the areas between each function and the x-axis. First, let's integrate the top function g of x. Now the bottom function f of x. Hopefully now it makes sense that if we take the first area and subtract the second, we are left with the area between the two functions. Instead of finding the area evaluating the two integrals separately, we can integrate the functions subtracted from one another. As an example, let's find the area bound between x squared plus 1 and x plus 3. First, we need to find the limits for our integral, which are the intersection points of the two functions. To find these points, we can solve the equations simultaneously. Now we can set up our integrals and subtract the area of the bottom function from the top. Instead of evaluating the two separate integrals, we can subtract the functions. Then we simplify that, integrate, and then pass the limits to get our final answer. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.